you've got space available for rent. I've never used it myself, but they've been very gracious to host us here for all the TriJs meetups, and they're really nice people. Also, thanks to JetBrains, we'll do a giveaway at the end for their one product of the month, which the one product you can pick their entire suite, so you can get all of them, but you have to make sure to pick the one product as their entire suite. That's the way it works. So, and then also to Tech Systems, if you're looking for a job or anything, they're great people to hit up. That's actually how Jerad and I met, and how we started working together was through connection with Tech Systems. So we've been working together for a couple of years now, I guess.
Yep, it's going on 2.
Going on 2.
Going on 2. In October, I believe.
But yeah, so everybody, this is Jerad Simpson, and he's going to talk to us about Git. Thanks.
All right. So when I put this together, I really don't know what a deep dive is. So this is really just a Git presentation. If there's a particular format to deep dive, I totally missed it. Moving forward, the first thing I have on the agenda is to just explain to you a little bit about what Git is. What we'll be learning is the command line. Git is a command line tool at its core that's used to interact with Git repositories. And then to go a little deeper into what a repository is. A repository is basically container that holds the history of every change you've ever committed to the repository itself. So you have, I have an illustration on the next slide here, but a commit then is something that you perform after you're done, hacking, making changes, adding, deleting, modifying files, that sort of thing. It's an operation that you perform which actually stores the set of changes in the repository. You'll see when you're looking at some documentation of Git, you'll see the word change set a lot, just a fancy term for like what a commit produces, and the illustration here should make that a little clearer. So this table at the very top is my simple Git repository. It has 3 commits, and we just talked a few minutes ago about how commits are really identified by checksums in this illustration. Hello. In this illustration, instead of using the confusing checksums, I just numbered them 1, 2, and 3 to kind of make things a little bit easier to visualize starting out. The other thing about this repository is that it has a branch, and every repository has at least one branch in Git. The default branch is known as master. That's by no means a branch you have to have in your repository. You can change the name of it if you like, but by default you'll get a master branch, and the content in each cell is basically kind of what a change set looks like. So in commit number 1, that's the initial commit, all we have is a bunch of additions. We add a README and 2 JavaScript files. Commit 2, along with adding those, of course, in the change set is the contents of those files. Commit 2, just as an example here, we have a modified README file, and I've added 4 new files, JavaScript files: shop, cart, item, and test. And then in the 3rd commit, we again modified README, shop, and we deleted test. So each of those cells represents a change set. It's good to know that in this simple repository here, commit number 3, you'll see quite often it's known as the head of that branch. Other source control providers might call it the tip of the branch, but Git, it's known as the head of the branch. That's the last, most up-to-date commit in that branch. So yeah, Git supports and encourages branching. Here you just see the one branch, but when you're working on a new feature or fixing an existing bug, which we'll be doing here as part of this, you'll typically be creating your own brand new branch that you commit files to in order to merge those over eventually into the master branch. All right, so for the purposes of this presentation here, I actually used a utility that we use at work. It's called Kendo. Kendo is a product made by Telerik, and it has a whole suite of controls that you can use, like drop-down lists, combo boxes. Well, what else do they have? Like grids.
If you've ever heard of, basically, if you open up Visual Studio and you look at all the different things you can throw into a form, like a text box, drop-down, anything at all, they've made their own version of it, and they're like a competitor to excuse me, Dev Express. So it's supposed to meant to get you up and running like really, really quickly, and it does do that for the most part.
Yeah, it is pretty awesome, and it does have its quirks like anything else.
Yeah.
So when I was putting this together, one of the cool things I thought is I reported a bug on their GitHub repository about a month ago. We'll wait for this train to go by.
That's a merge conflict.
That happens every time.
Stylized stuff?
Yeah, I'm going to get out of this presentation here and show you just briefly.
Okay.
It does style.
I know similar. I mean, I just started, but like, is it like Bootstrap kind of how it is, but for forms, I guess?
Yeah, it's like yeah, you can compare it to Bootstrap.
Library or framework?
Yeah. So, let me back out. No, it's okay.
Off track, but
It's quite all right. Let me see here. I know that that's impossible to see unless I zoom in, and not that much. So, okay, here's how they describe themselves. Kendo UI Core is the project we're looking at, an HTML5 jQuery-based widget library for building modern web apps. And just click the link, and maybe they'll have some cool demos here for us to look at. I don't know. UI components, that sounds about right. Let me back out. Look at examples, maybe.
That was like a really old version of their website.
I was gonna say.
Yeah, that did look very old.
If you go to just telerik.com, there should be something there for like demo.kendoui.com, I think. Maybe.
Compliment the idea. I mean, I think you're right. It's gotta be like Bootstrap.
I've noticed a lot of websites.
docs.telerik.com.
I mean, it looks like
No, it keeps redirecting to that site.
Unless other people are doing similar style, but
Yeah.
I've noticed like in the last month, like a couple websites I go to, like have changed, and then it's all Bootstrap stuff. I'm like, that's easy.
I think Spark Plaza might have something going on here where they're redirecting Telerik to a fake website. I have no idea. That's probably not true, but
I can't read what the URL is, but it doesn't look like
it's findingresult.com and then searching for some Telerik. So it's like a DNS redirect sort of thing. Might be having some DNS issues finding their site. I have no idea. GitHub seems to be working. So I will show you. This isn't the best demonstration of everything that they have. This is their simple drop-down, or combo box, I should say. Let me refresh this and make sure we can get to this. Okay, so yeah, this is one of the cool controls that they have. It's a combo box. You can type whatever you want into here. If nylon or whatever is the t-shirt fabric that you want, you can type that in. The whole point of it, though, is to select and keep duplicates kind of away out of the database, that sort of thing. So here's actually a demonstration of the issue that we were looking to fix here. I start typing cotton, and suddenly it thinks it wants to add a closed parenthesis at the end. This is a bug that we found that existed within Kendo, so I took a stab at hacking that to fix it, and show you what it looks like on my test. This is post-fix. So if I start typing cotton, it actually does select the right one. It turns out that's just one line of code, but while we're going through the presentation, you'll see a lot of cool Git commands that'll teach you how to use Git while we're making this one line of code change. You're going to think, wow, that's a lot of stuff for one line of code, but bear with it. All right, so step one, of course, is to clone the repository that you want to work with. So here, the top 2 lines, that's actually one command. You would type this out just on one line inside your terminal window. Git clone and then the address that you're cloning. When you go to their site on GitHub, there's usually a button right on there that says clone. You click on that. It might give you 1 or 2 options on how you want to clone it via HTTPS or SSH. It doesn't matter which one you choose. Git clone kind of accepts all sorts of protocols. Git is its own protocol that it accepts. SSH is the other one, and here you see HTTPS. So what this command actually does then is first creates a new directory wherever you're running the command in your terminal. It's going to create a new directory in the folder that you're in, named after the project that you're cloning. So in this case, you get a folder called kendo-ui-core. And inside that folder, you'll see another folder called .git. That's a convention on more like Linux, Unix machines. A convention for like hidden files and hidden directories is that they begin with the dot character. And that's why it's named .git. But when you're browsing in that folder, I generally unhide all the files, and you can see that there's a .git in there. Don't go around making any manual changes inside there unless you really know what you're doing. It contains the history, the entire history of the project, and some configuration where if you did know what you were doing, you could go in there and pop a line of configuration stuff in one of the files inside there. But the last thing it does, instead of just creating that .git folder, is it checks out everything. It automatically creates all the files at the head of the master branch within the directory. That's also known as, or very similar to, running the Git operation, Git checkout master at the bottom there. That just basically populates the directory full of all your files. All right, this one I wanted to introduce very, very early. So you've seen Git clone, Git status. It's a magical command. Based on the context of what you're doing, the output of Git status changes, and it often will tell you exactly what you need to do next. So it'll show you things like a list of all the files that are new, deleted, copied, modified, or if you're doing a merge or a rebase operation, which we'll barely touch on in this, but when you're doing that, it'll show you instructions on how to continue or finish those operations if you get stuck, or how to fix a commit, or it'll give you a list of all the files that are committed and tell you how to fix them, what to do after you've fixed them, that sort of thing. It'll also tell you how to discard the changes that you make to to files that it lists. If there are modifications, it'll tell you how to discard them or add them to a commit. And you'll see examples after this, so hopefully it'll become a little more clear. But there's a lot of power in just typing git status right there in the command line. All right, this is where I'm hoping you guys can see. It's a little bit small. Maybe I can talk you through it and it won't be so bad though. At the top here, I've just run git status inside the brand new cloned repository. It's a little bit old at this point. What the repository, what the git status command is telling me about this repository is that I'm on the master branch. That's the second line of output. The third line is telling me that I'm behind, that there have been commits that have taken place since I cloned this repository. It says I'm behind by 4 commits, and it can be fast forwarded. Basically, that means right below that it says use git pull to update your local branch. When I use git pull, it basically just grabs all the changes and fast forwards, changes all the files that I have checked out to bring them all up to date. So I haven't covered git pull yet. That's another operation, but I'm going to go ahead and take the advice of git status and run it. So right here, I'm running git pull. And you can see it pulls what looks like 4 files. 4 files, 72 insertions, and 3 deletions to bring my working files up to date with what's in the repository. The next thing that I'm doing here, I also have not covered yet. Is a git checkout. I mentioned git checkout when I talked about cloning the repository. When you clone the repository, it'll automatically check out the master branch for you. Well, here I'm actually using the git checkout operation to create a new branch, and that's what the -b is for, right here. And then you can name a branch anything you want. So I just name this one something long, fix, combo box, filter, suggest. It kind of describes what I'm doing, maybe not the best terminology, but all that command does is takes the current point in where I am currently on the master branch. What it does is it takes and kind of forks that into a brand new branch. Where I can work on things, create my own commits and that sort of thing without messing with the master branch. It's a typical workflow. You're going to see that a lot. It's discouraged a lot of times to make commits directly to the master branch. So you'll see everybody when they're working creating their own branches, and they can name them anything. So here's another explanation of the second thing that we did, git pull. There's another form of git pull, which you can run by adding 2 dashes and the word rebase. At the very end of the presentation, we'll cover merge and rebase a little bit. But what you should understand about git pull is it actually performs 2 operations when you run it. It performs a git fetch on your behalf, which grabs all of the latest changes from the remote repository, and then it either does merge if you run the top command or rebase if you run the command below that. They both accomplish the same goal in just different ways. They accomplish the same goal. So merge and rebase incorporate the changes that are fetched from the repository into the files that are currently checked out, into the currently checked out branch, if applicable. If I can back up for a second though, and The reason I put if applicable in there, this fix combo box filter suggest is a brand new branch. It doesn't exist yet on any remote repositories. So if I were to do a git pull on this branch, Git would actually output and tell me, well, what are you doing? I don't know of any remote branch to pull from, and then you have to specify a little bit more information in order for that command to succeed. Hack, hack, hack. So this is part of the JavaScript that Kendo has, that specifically I'm on the line that was changed in order to apply the fix. You'll see a little bit more of that here coming up. We'll show another 2 examples of Git Status, and this kind of drives home the point that it holds your hand through a lot of it. It tells you what to do so that I don't have to. But I will go over it. If I run Git Status after I've changed a file, it shows up in red. That's hard to read, and I can't highlight it because it's a picture, but it's telling me that I have this source directory. Inside the source directory, there's a file called kendo.combobox.js, and it's telling me above that it's not staged for a commit. There's a funny thing about Git when it comes to staged and unstaged changes. In this particular instance at the top, we have an unstaged change. When you make changes to files, you can't just go directly and automatically commit those changes and expect them to show up in your Git repository. There's a couple different ways you need to go about it first. I'm going to follow the instructions here, and it tells me right on this line that I can use git add and then the name of the file in order to update what will be committed. So this takes the source Kendo combo box JavaScript file out of the unstaged bucket and puts it in the staged bucket. So I've run this right here, and then immediately after I run Git Status again, and it's telling me that everything looks good, and you can even tell that red changed to green. That's promising. Along with instructions, like I mentioned earlier, if you were to want to unstage the file, if you completely messed up and didn't mean to do that, it gives you a tip on how to do that too by running a git reset command against the file. Just read what's on the screen a lot of times, and you're pretty good to go. I will talk a little bit about git add, because it does seem to be a little painful sometimes. You would think, how many of you guys have ever used Subversion, SVN, or any other source control? All of y'all?
Yeah, not quite, but
Most.
Visual Source Safe, CVS, PVC.
So you go way back.
But I'm not using BitKeeper.
Yeah.
Or there's a bunch. I don't think I've even used Mercurial. A lot of people use Mercurial.
Yeah.
Yeah.
Mercurial is kind of like, I would say it's probably the main competition to Git. The way it works is very similar. I haven't used it in a couple of years though, so it might have an advantage over Git at this point, or no.
I used it in my last job. I'm just kidding now.
All I can say is there's... Yeah, okay. Originally, I wanted to learn Mercurial. Just, off on an aside, I thought that the commands, the operations, the subcommands made a lot more sense the way that they were worded than some of this push-pull Git stuff. But I think the market has spoken, and Git is everywhere, and Mercurial you'll still find in some places, but
In fact, it's called GitHub.
yes,
Mercurial Hub.
exactly.
Yeah.
Git sucks. I don't care what the market says.
And yeah, I can see the point too. I can see that point, but JavaScript does too, right? And this is TriJs.
There was nothing worse than just Microsoft's visual sourcing.
That was bad.
Pretty bad,
That was
yeah.
the worst.
Yeah.
It had a menu item called like repair.
Yeah.
It's like Microsoft Access. Like it says, you go to tools and it says repair database.
Yeah.
Like no, you should not. That should not be like a feature.
Yeah, I
You
know.
Repair your database.
Because obviously it's going to break.
They stored your data in a very strange way too. But the point I'm getting at here is, you, especially coming from SVN, you expect to just be able to make your changes and commit them without an.
Do it all in one step.
You can. I'm gonna.
Does anybody ever actually add
The,
really? No,
Yeah.
git commit -am instead of -m in your message adds it.
yeah. It does. I'm actually going to mention that here in a few moments. The problem with that is that it does not pick up new files that you add. It'll pick up any modified files that you add, but any brand new files, you still have to go through this git add operation.
No, I'm not. That's why I'm
Maybe you
always
left
adding.
some files out.
Whoops. So really, I don't even know why I put git rm on here, because it's the same thing as git add. It's kind of there for convenience, I guess. But the very top form is how you would just add one file to the stage to be committed, to be included in your commit. There's a little trick that you can perform, which is that second line of code where you do a add operation with a dot, and the dot represents the current directory that you're in, and the -- all on this command actually does pick up new files. So if you have modifications, deleted files, and new files, if you use the second form, it'll include all of those, add them all to the stage so that you can then commit them. You want to be in the root directory of your repository when you do that. So if you were in a subdirectory like source, the source subdirectory, and you ran that second add command up there, it would just basically make sure that everything in the source directory and in subdirectories of that were staged. This command is one that I typically run, especially if I'm adding new files as well. The git rm, if you know a little bit of shell scripting, rm means remove. It normally rm and then a file name removes that file. Well, git rm does the same thing. It removes that file, but it also automatically stages that file deletion for you. So it's a convenience thing. You could remove the file and then stage that change with the git add. It's kind of weird that you would do git add when you're removing a file, but this is that intermediate step that might cause some problems for some people. And if you forget it, you'll typically recognize it because run Git Status. Keep running Git Status before or after a lot of these operations, and it'll give you a list of things, and if your list doesn't match up with your expectations, you've done something wrong, and it's pretty easy to fix.
I hear that all the time from the Git, blaming the victim. It's always my fault.
Yeah.
If I type all that crap in, they better add files that I haven't even created.
Yeah, I wish it did everything for us.
Git will also punish you if you wait a really long time to do your commits.
Yeah.
And you keep out of sync. I'm sure Jared will-
I can make a quick little comment on that. Is I've had most troubles with rebasing And that's actually something that we're doing a little more often. I will talk about rebasing at the end, but you're right. If you're out of date and you're doing a big rebase operation, a lot of times it does it in increments. It does it in steps. So it takes all of the commits you've made and then applies them on top of, new commits that you're just now pulling into the branch. So what can happen, and what frequently does happen, is you'll mess up when you're trying to resolve that first conflict, and then every commit afterwards you have your own commits conflicting with your previous own commits and later own commit. It gets crazy. So yeah, it's a good idea. Stay up to date as much as possible, and Git pull will help you do that.
Is there like a best practices for how often?
I do it at least every day, once a day.
I typically pull changes before I stage anything.
Yeah.
So then you can kind of figure everything out, but once you've staged your changes and you pull and you've got a merge conflict, it becomes a little bit of a mess to fix it sometimes.
So Pat, another coworker of ours, he kind of does the same thing, and I did not mention that in this presentation, but Git Stash, for the ones taking notes, it's a very useful operation to know. I'll explain it real quick. So Git Stash will basically it takes your stage changes, I believe. So you might want to stage your changes first. It's not always entirely true, I don't think. It can pick up some unstaged changes too. But what it does is it puts it in a temporary workspace for you. So if you want to take everything, all the changes that you've currently made and are working on, and just put them away temporarily, you can use Git Stash. That's all you have to type as a command is Git Stash. Then you can pull changes down, do whatever you want. You can even switch branches, go work on another feature, switch branches back at some point, and then you want to pop those changes off of your stash. So you'll use an operation called Git Stash Pop. And basically that takes what they put in your temporary working space and brings it back down into your on top of your files that are currently in there. I use it a lot. I don't know why I didn't put it in here. It really is pretty common. Git Diff is also very common for me. I know not everybody uses this, but I defined it here as a useful operation to review changes or compare trees. A little bit of quirkiness with the first two commands. Git Diff on its own will show you the changes that you have made currently on your branch that are unstaged. Git Diff with the cached flag afterwards shows you all of your staged changes. So there's a little bit of a difference between your output depending on which Git Diff operation you choose to use. The best one, in my opinion, to know is the last one. So if you're getting ready to merge your changes from, you're working on a feature, brand new cool feature, and it's on your own branch, and you're getting ready to merge that over to master. If you run that last command, git diff master head, what that does is compares the head of the branch you're currently on to what's in master. So you can see, a huge list of all of the changes that you've made between, since you've been working on head and how it relates to master. So see, the cool thing about, when you're doing branching, when you're branching and making a lot of commits, making commits very often, you might have in your feature branch 10, 20 different commits for, separate things. One commit you might work on the feature itself. Another commit you work on unit testing. Another commit you maybe fix a bug that you found in your business logic. In this one Git Diff command at the end, you can compare, okay, all of those changes from that branch compared to master, and you'll get to see it in action. Here's an example, a very huge example. No, this is just one line of code. That was the red one. I don't know if you can see the minus sign on the left-hand side, but the Git Diff here is one line of code removed and one line of code added. And that fixed our bug that we're working on. So let me see if there's anything else here that's noteworthy. In the previous step, I ran the git add operation, so this file is staged. In order for me to print the diff at this point, I did need to make sure that I used the cached operation, or the cached option to the diff operation. And now we're going to talk about commits and how you can, take some shortcuts in some situations. So the first thing, Git commit on its own only commits staged changes. If you run it, you might be surprised, but it's going to, pop up an editor in your face and tell you, okay, write me a commit message, and you do need to write a commit message in order for it to be committed. I'm not using that form in the demo. I'll be using the second form. You can supply your message right on the command line by using the M flag or M option, followed by the message that you want to commit. And then the third option has the -A in there, the all option, if you will. And it will automatically stage files for you prior to the commit so that you can mostly eliminate the need for git add. I made that note at the bottom, it does not stage new files, because that has burned me a couple times. And you'll run into it eventually, I'm sure. Let's see here. So yeah, that's git commit in a nutshell. And here's a huge example of it. A lot of this text, I know you can't read it anyway, but it's just a jumble of output that is telling me stuff I really don't care about. But the very first top line of the command is what I'm interested in. That's when I'm actually running git commit with a message. My message is that I'm fixing the combo box, the contains filter plus suggest prefers best match instead of first match, and then I included a bug number on there too. A lot of this was, I tried to write my own commit message a lot shorter. It turns out that Telerik has some hooks in their Git, how you commit to a Git repository that's either forked from them, or how you commit to their Git repository. They actually enforce a specific pattern that you have to follow, and anyway, I had to kind of play with that to get the message right. But just like I said previously too, we just have one file changed, one insertion, and one deletion. That's what you just saw in the Git Diff operation before. Here's a new one for you. Git push. So we talked about git pull already. That's how you grab changes from a remote repository. Git push is how you give changes back to a remote repository. And rather than trying to read a lot of that small text, here we go. So the form I just used is the very top form, git push. The -U flag I'll explain here in a second, but you'll see git push include the origin a lot of times, and then the branch name that you're pushing. Origin is a little noteworthy at this point because you've probably seen it a couple times. I know you're seeing it now, but I think a couple slides ago we had origin as well. It's an alias. Basically, when you clone a repository, it points to the address of that repository that you've cloned. It's called origin by default, but that can be changed as well. And to make matters a little more confusing, you can actually have multiple remote repositories. So I can have a remote that points to my GitHub and a remote that points to Larry's GitHub to work on this feature. So anyway, it's worth noting origin. You'll see that a lot. The U flag is a simple way of telling Git to remember that once you're done committing this branch to the origin or to the remote that you choose to commit it to, origin in this case, it's telling Git to remember that, so that when you push things in the future or when you pull things from that for that branch in the future, it doesn't have to. You don't have to specify it over and over again. So the very first time I push a new branch to a repository, I use the top version of this command. Anything after that, the middle version's fine, just a simple git push. The third option is a little bit different. When you get to the point where you're finished with a branch that you're working on, if it's a feature branch that you've already merged and it's already in your master line of development, you're going to want to delete it, clean up your, what might be a huge list of branches. When you delete a branch from your local machine, it does not delete in the remote repositories. So that last command's just a really simple, quick way to specify that you want to delete a branch from a remote repository. You specify the 2 dashes and delete option before the branch name. And that is git push in a nutshell. All right, we're on the home stretch here. There's not a whole lot more information I have for you guys. A few more examples here. And then I'll open it up for questions and that sort of thing. Gitignore. This is a file that you'll typically find. It exists in the root. Well, it can exist in any directory in your repository, but you'll typically find one in the root. And gitignore tells Git, don't worry about these files. For instance, I know a couple of you use Macintosh. A couple of you use Macs. This DS store is kind of a file that gets created on its own, I believe, on Mac OS X. This dist folder here, that's normally a distribution folder. That's once you build this project, it throws a ton of files inside there. These are files that we're not really interested in Git tracking them at all, because no matter what, we have all the code we need to generate those files already. So if I were to go and say remove this dist folder right here from gitignore, and then I type git status after removing that, you're going to see, oh, I have 35 files that are waiting to be staged and waiting to be added to my repository. But it's important to know, just like svn ignore works the same way. You just files you're not interested in storing. These last visuals here, I ripped these directly from the Git manual pages. I like the ASCII art that they show. So I'll just go ahead and read this here. This is how a Git Merge works. This is also, in my opinion, the easiest way to bring changes into a branch. It's the least error-prone way, but it's the way that generates a history that looks crazy. So assume the following history exists and the current branch is master. So you're on the master branch right now. The master branch contains commits D, E, F, and G. And you guys see that on the bottom line there. The topic branch above it, when that was created, the master only had commits D and E. It didn't have F and G, but when it was created, whoever created this topic branch added 3 commits, A, B, and C, to that topic branch. You're on master. When you run the merge operation, you would specify Git Merge and then the branch that you want to pull into master. And the explanation here from the manual pages says it will replay the changes that you made on the topic branch since it diverged from master, i.e. E. That's the commit where it diverged from master, until its current commit C on top of master, and record the result in a new commit along with the names of the two parent commits and a log message from the user describing the changes. You don't have to worry about, you don't have to worry too much about the log message from the merge commit. Those are pretty standard. You're going to see those log messages quite often. Topic branch merged into master is something like it would say. But the thing to note is when you do this operation, it does create a new commit H at the bottom right when it brings that into master. At this point, you could delete your topic branch. It's no longer needed. You could keep it around and continue development on it as well. It's kind of up to you and your workflow, and I'm not going to prescribe a particular workflow to you guys. There are several different ways to work with Git out there. But it's good to know it creates that commit H. Here's rebase, and rebase works differently. Again, like before, assume the following history exists in the current branch's topic. We have the same exact art here, D, E, F, and G. It diverged at E, and the topic commits have commit A, B, and C. From this point, the result of either of the following commands, and I would use the first one typically. If you're in the topic branch and you choose Git Rebase Master, what it does then is it pulls in, first it actually rewinds. What it does is it takes commits A, B, and C away from the topic branch and kind of, I don't know how it works internally, but in my mind it stashes them away. Then it pulls in the commits F and G from master, and then it tries to replay your commits on top of that. So you see at the bottom the art says A prime, B prime, C prime. The reason those primes are there is technically when you're doing this operation, you're rewriting history a little bit. It makes things a little nicer to read. It makes things nicer to peer review in a lot of cases, but it can also cause a lot of pain when it comes to fixing conflicts. If you mess up fixing, one of your first conflicts, like I mentioned earlier, almost every subsequent commit that replays on top of that will cause a conflict as well, and it can be a lengthy, error-prone operation. Nevertheless, a lot of companies actually mandate its use because it makes the history that much nicer to read. It keeps everything linear like you would be used to reading with a source control provider like SVN Subversion. All right, and nothing's really complete without showing you git log. All this is you type it, and you can scroll up and down through the list of every single commit that's ever been made. You're finally seeing for the first time, perhaps, in yellow, if you can read that. My eyes can't. Those are the SHA-1 checksums that we were talking about earlier.
Broken.
Yeah, it is. It's not broken in Git yet, and it probably. What's that?
I said you were up late last night.
I was up really late last night.
12:37.
It was about 12:30 when I did this. If you're wondering why the presentation is not a little more complete, it's because I waited till the last minute. But yeah, it'll show you the complete history. You can scroll up and down. You can use other tools like grep, and if you're familiar with grep, to kind of like search through things, or this is there's a million ways to search through this log, really. I'll leave that as a user exercise. Here's another interesting way to visualize things. This might help in some situations. Git is far from linear. Typically, most projects, you're not going to find a very linear workflow with them. You can see that in this example. All those colored lines at the left-hand side represent different branches. And eventually, they all merge into one. What I didn't show you is at the very top of this, I had to scroll down a little bit to get a really good, looking branch thing. But at the very top of that, everything does merge back into just one line of, or one branch, which is pretty cool. But here you can tell they were really sprinting to get something done. I can read it, but y'all can't. Apparently, Switzerland does not use the Esset character, which is a character I know the German language uses. But anyway, read the commit messages. They're interesting. And that's all I got right now. So thank you. The credits that I've given to this, of course, a lot of the stuff I pulled or were inspired from just reading the Git manual. When you install Git, you can access the manual a lot of times by typing Git and then the command that you're interested in, and then -- help, and it should launch a page for you to read a little bit more about what that does. Thank you to Telerik and their Kendo UI core for giving me something to fix. LibreOffice Impress. That's what I put the presentation together on, and I have not ever used this before in my life. and I wrote it. So if you need to get into contact with me, if you have any questions after we leave here tonight, my email address is jbsimpson. The B stands for Brooke. That's my middle name. Pretty easy to remember, at gmail.com.